Welcome, learners. You are welcome to section 4 of STAR 202. In the last session, I discussed with you about multiple linear regression. In this section, I will be discussing with you the test of hypotenses. At the end of this session, it is expected that you will have learned about test of hypotenses. You will have learned about different conditions at which hypothesis testing can be conducted. You will also have learned about the difference or different types of errors we have in hypothesis testing. You also have applied hypothesis testing to different data sets which represent different scenarios or real-life situations. Hypothesis testing. In every experiment that we conduct, we obtain data set. This data set does not make sense unless scientific investigation is conducted to know the significance contained in the data set. And this scientific investigation is the testing. This scientific investigation will require for you to set a statement about your population. This statement is called hypothesis. A statistical hypothesis is an assumption or a statement which may be true or not about your population. However, such statement is subjected to further scientific investigation in order for you to make conclusion about the population. Again, our attention is on the population, not on the sample. So any inference you are making will be made about your population, though you may be making use of sample data sets. But all inferences will be made about your population. So a statistical hypothesis could be null hypothesis and could be alternative hypothesis. A null hypothesis is that hypothesis that is set about your population upon which you are interested to conduct scientific investigation on. And this hypothesis is represented by default as H subscript naught. If testing null hypothesis, you realize that the null hypothesis is not true, then you have to go for another hypothesis, which is called alternative hypothesis. So alternative hypothesis is set to be a backup. In case if the null hypothesis fail, then we can go for the alternative hypothesis. However, our attention is on the null hypothesis, not on the alternative hypothesis. So the alternative hypothesis is represented with H1. There are two types of error that may occur in hypothesis testing. If after testing your null hypothesis, which is our area of focus, and you realize that you need to accept the null hypothesis, but unfortunately you mistakenly, by error, accept or reject the null hypothesis when you're supposed to accept, then such error is called type 1 error. On the other hand, type 2 error will have been committed if after testing your hypothesis you realize it is false and you need to reject the null hypothesis, but you eventually accept it, then such error will be called type 2 error. So the probability of committing type 1 error or type 2 error are represented with alpha or beta respectively. So alpha is called the size of the test, where 1 minus beta is called the power of the test. So 1 minus beta 1 minus beta is the probability of rejecting the null hypothesis when it is false. The area that falls under the rejection of null hypothesis is called the critical region. The area such that if the sample point falls in it when we reject null hypothesis is called the critical region. When the primary concern of the test is to see whether the null hypothesis can be rejected, such a test is called a power of significance. In that case, the alpha is called the level of significance at which the test is being conducted. There is one-tail test, and we also have two-tail tests, types of the tail of test. The alternative hypothesis determine if it is one-tail test or two-tail test. It will be one-tail test. Take for example, in the first equation, the equation we have here, look at the alternative hypothesis H1. If it says theta is greater than theta naught or theta is less than theta naught, by greater than means that it falls to the right hand side of the distribution, and by less than means that it falls to the left hand side of the distribution. So in such a case, it is one-tail test, because it is when it is greater than, it means it falls to the right hand side. When it is less than, it means it falls to the left hand side. That is, one side is known. However, if the alternative hypothesis says theta does not equal to theta 1, it means it can either fall to the left hand side or it falls to the right hand side. So in such a case, we have a two-tail test. Again, your alternative hypothesis determines if it is one-tail test or two-tail test. Procedures for conducting statistical hypothesis testing. 1. State your null hypothesis and write down your alternative hypothesis. 2. State the significance level. It is very important you state the significance level before you proceed to the test statistic, which is in step 3. You have to know the appropriate test statistic you are using based on conditions on ground. Please get it right. It is called test statistic. There is no S at the end of that statistic. So it is called test statistic. The fourth step is for you to make decision whether to reject or to accept the null hypothesis. The condition for this decision will be mentioned as we progress. Finally, make inference about your population based on the result you have obtained. This inference that you make is what a layman, an ordinary man, will understand about your hypothesis testing result. Let's consider the first condition of test of a hypothesis. When the sample size is large, when the sample size is large and the distribution, the data set you have on ground obeys the normal assumption. Also, you must also know the population standard deviation. Then the Z test statistic is appropriate to be used in this case. This statistic is presented here. Z equals to the sample mean minus the population mean divided by the standard error of the sample mean, where the standard error of the sample mean equals to the population standard deviation divided by the square root of the sample size. We take a case study. A bottling company, for example, who bottles soft drink for a consumer, claims to have 35 cl quantity in the bottle which she produces with standard deviation of 0.75 cl. A researcher randomly has collected 50 bottles of the product from this company, has measured the contents and realized on average the bottle has 34.2 cl content. The instruction says further, test this process or the outcome of this research at 1% significant level that the bottling company has been cheating on their consumers or not. Yes, so from the question, we will see that the population standard deviation is given. The population is given as 0.75 cl. The population mean is given as 35 cl. The sample size is 50, which is greater than 30, so it is large enough. So, and the sample mean is 34.2 cl, while the significant level is 1%. So, I want to obtain all this. We can then go ahead to set the null hypothesis. Setting the null hypothesis is that the claim of the company is that the population mean is 35 cl, where what the researcher has obtained is less than, so the population mean is less than 35 cl, that is 34.2 cl. So the z-test statistics is obtained. Of course, we know our significant level, which has been given as 1%. Next, we go to the appropriate test statistic, which is the z statistic. So we substitute those necessary parameters into it, and by further simplification, you obtain the value of calculated z to be minus 7.54, and the absolute value of the calculated value of z to be 7.541. So the tabulated value will be obtained from the table, where the calculated value is 7.541. When you check the normal distribution statistical table, you will obtain the z statistical table to be 2.33. Here it can be seen that the calculated value 7.54 is greater than the tabulated value 2.33. Hence, we then decide to reject the null hypothesis at 1% significant level. Hence, we are concluding that the bottling company has been cheating our customer at 1% significant level.